Artificial intelligence is growing faster than almost any technology in history. Every AI chatbot, image generator, scientific model, and autonomous system depends on enormous computing power operating every second of the day. Around the world, companies are constructing giant AI data centers filled with tens of thousands of processors. These facilities consume astonishing amounts of electricity, making AI one of the fastest-growing sources of new power demand. What appears to be a software revolution is rapidly becoming an energy revolution. Behind every intelligent response is an enormous physical infrastructure that few people ever see. But it may become one of the most important engineering systems of the 21st century. Electricity infrastructure was never designed for AI's explosive growth. Utilities can take years to build new substations, transmission lines, and power plants, while AI companies need electricity immediately. Across the world, hundreds of new data centers are competing for limited grid capacity. In many regions, projects are delayed not because they lack financing or computer chips, but because there simply isn't enough electricity available. The bottleneck has shifted from computing hardware to energy infrastructure. Solving this challenge has become one of the defining engineering problems facing the artificial intelligence industry. Massive AI campuses are appearing across the globe. These are no ordinary buildings. Inside are thousands of servers, networking equipment, cooling plants, electrical switchgear, backup systems, and sophisticated control rooms operating continuously. They represent billions of dollars of investment and have become the factories that manufacture intelligence itself. Every completed campus increases demand for reliable electricity, forcing engineers to rethink how power is generated, delivered, and managed. The physical infrastructure behind AI is expanding at an extraordinary pace. Companies like Microsoft, Google, Amazon, Meta, and OpenAI cannot afford power interruptions. Even a few minutes of downtime can disrupt millions of users while costing enormous amounts of money. AI systems must remain available 24 hours a day, every day of the year. Waiting several years for new transmission infrastructure is no longer acceptable. Instead, technology companies are searching for new ways to produce electricity directly beside their data centers, creating independent power systems that operate regardless of grid limitations. Hydrogen offers an entirely different approach to powering AI. Electricity can first produce hydrogen through electrolysis. That hydrogen is stored until needed, then converted back into electricity using fuel cells. Unlike solar and wind, fuel cells provide continuous, dependable power regardless of weather or time of day. Instead of replacing renewable energy, hydrogen complements it by storing excess electricity and making it available whenever demand rises. What was once viewed primarily as a transportation fuel is now emerging as critical infrastructure for artificial intelligence. The hydrogen system operates as one continuous engineering chain. Renewable electricity powers electrolyzers that split water into hydrogen and oxygen. Compressors increase the hydrogen pressure before it is stored inside specialized tanks. When electricity is required, hydrogen flows into fuel cells, where an electrochemical reaction produces electricity, heat, and water. The process contains no combustion and produces highly reliable electrical power. Together, these components create an independent energy ecosystem capable of supporting AI data centers around the clock. Artificial intelligence has triggered a completely new competition, not only among software companies but also among energy providers. Fuel cell manufacturers, hydrogen developers, utilities, engineering firms, and infrastructure investors are racing to supply electricity for the world's fastest-growing industry. Reliable energy is becoming just as valuable as advanced computer chips. Companies capable of solving AI's electricity problem may become some of the most important players in the future digital economy. Bloom Energy has become one of the pioneers in this transition. Its solid oxide fuel cells generate electricity directly where it is consumed, reducing dependence on distant power plants and overloaded transmission networks. Instead of waiting years for new grid infrastructure, AI companies can install modular fuel cell systems alongside their campuses. This distributed approach improves resilience while allowing computing capacity to expand much faster. Local power generation is rapidly becoming an attractive solution for AI infrastructure. Fuel cell energy is pursuing utility-scale projects capable of supplying hundreds of megawatts of electricity. These installations demonstrate that fuel cells are no longer small backup systems. They are evolving into large, continuous power plants. Utilities and technology companies increasingly view hydrogen fuel cells as dependable baseload generators capable of supporting major industrial facilities and AI campuses. The technology is steadily moving toward the same scale as conventional electricity generation. The hydrogen industry is expanding beyond transportation. Companies that once specialized in hydrogen fueling stations are now adapting their expertise to stationary power generation. Compressors, storage systems, hydrogen distribution equipment, and control technologies originally designed for vehicles are finding entirely new applications inside AI infrastructure. Artificial intelligence is creating an unexpected new market that reaches across the entire hydrogen supply chain. For decades, diesel generators have protected data centers during emergencies. However, they are noisy, require extensive maintenance, emit pollutants, and depend on constant fuel deliveries. Fuel cells generate electricity differently. They use electrochemical reactions rather than combustion, allowing quieter operation with fewer moving parts and significantly lower local emissions. For facilities expected to operate continuously, these advantages become increasingly attractive. Fuel cells represent only one part of a much larger engineering system. Hydrogen must first be produced, purified, compressed, transported, stored, monitored, and delivered safely. Electrolyzers, compressors, storage vessels, valves, pipelines, sensors, pressure regulators, and automated controls all work together to ensure continuous fuel supply. This invisible infrastructure forms the foundation that allows hydrogen-powered electricity to operate reliably. Future AI campuses are unlikely to depend on a single energy source. Instead, they will combine solar panels, wind farms, battery storage, hydrogen storage, fuel cells, and grid electricity into one intelligent energy system. Advanced software constantly balances power flows between these technologies, maximizing efficiency while ensuring uninterrupted operation. Hydrogen provides the long-duration storage that renewable energy alone cannot always deliver. Utilities recognize that artificial intelligence will become one of the largest sources of future electricity demand. Rather than replacing existing grids, distributed hydrogen systems can reduce congestion while improving resilience. Generating electricity directly at data centers eases pressure on transmission infrastructure, while allowing utilities to serve growing demand more effectively. Hydrogen is becoming an important partner to traditional electrical infrastructure. Fuel cells are undergoing a remarkable transformation. Once considered emergency backup systems, they are increasingly viewed as continuous baseload generators operating every hour of every day. This shift dramatically improves project economics because equipment remains productive instead of sitting idle waiting for outages. As hydrogen costs continue falling, continuous fuel cell operation becomes increasingly attractive. Electricity has become one of the largest operating expenses for AI companies. Modern data centers consume enormous amounts of power every day, making energy costs a major factor in profitability. Reliable electricity also reduces financial risks associated with outages and service interruptions. Investing in dependable energy infrastructure has become a strategic business decision rather than simply an engineering requirement. Future AI campuses may require hundreds of megawatts, or even a full gigawatt, of continuous electricity. Fuel cells offer a modular solution because additional units can simply be installed as demand grows. Instead of constructing one enormous centralized power station, developers can expand capacity gradually while maintaining high reliability. This scalability makes hydrogen particularly attractive for rapidly growing AI infrastructure. The AI energy revolution depends on far more than fuel cell manufacturers. Electrolyzer companies, compressor suppliers, storage tank manufacturers, valve producers, sensor developers, cooling specialists, software companies, engineering firms, utilities, and construction contractors all contribute essential technologies. Behind every AI response exists an enormous industrial ecosystem working together to deliver reliable electricity. Hydrogen production plants, storage terminals, pipelines, transport systems, fueling hubs, and distributed power stations are gradually becoming part of tomorrow's infrastructure. Similar to how highways enabled automobiles and fiber optics enabled the internet, hydrogen networks may become another hidden system supporting the digital economy. The infrastructure being built today could define how AI expands over the coming decades. Countries around the world understand that abundant electricity will determine where future AI investment occurs. Nations capable of producing clean energy while deploying hydrogen infrastructure may attract the largest AI campuses and associated economic growth. The race is therefore no longer just about software, it is equally about engineering, energy security, and infrastructure development. Electrolyzers continue becoming more efficient while hydrogen production expands worldwide. At the same time, AI computing requirements continue increasing. These trends are beginning to intersect, creating one of the largest emerging infrastructure opportunities in modern engineering. The next decade will reveal whether hydrogen becomes a mainstream power source for artificial intelligence. Hydrogen-powered electricity extends well beyond data centers. Hospitals, airports, semiconductor fabs, pharmaceutical plants, military facilities, and financial institutions all require uninterrupted power. The same technologies supporting AI can strengthen resilience across countless critical industries. Investments made for artificial intelligence will likely benefit many other sectors as well. Artificial intelligence depends upon countless engineering systems operating invisibly behind the scenes. Electricity generation, cooling systems, communications networks, hydrogen infrastructure, and advanced industrial equipment all work together to support every AI interaction. Understanding these hidden systems reveals that engineering, not software alone, is what truly powers modern civilization. Every technological revolution has required new infrastructure. Steam engines required railways. Electrification required power grids. The internet required fiber optics and data centers. Artificial intelligence now requires resilient energy systems capable of operating continuously. Engineers designing hydrogen plants, fuel cells, storage facilities, and intelligent power networks are helping build the invisible foundation beneath tomorrow's AI economy. Every hidden machine tells a larger engineering story. At H2 Hub by Renewable Energy, we help engineers, students, investors, and industry professionals understand the complete systems behind hydrogen, fuel cells, electrolyzers, compressors, storage technologies, industrial equipment, and clean energy infrastructure. Through engineering schematics, equipment libraries, calculators, technical learning, and project databases, H2 Hub reveals the machines powering the global energy transition. Visit h2hub.renewable.com and discover the engineering behind the future.